So here I've got a quadratic equation, a pretty simple one where you can easily factorize and solve for the roots. And I'm going to use this as an introduction to roots of polynomials. So we can see here that if you add the two roots together, so 2 minus 2 minus 1, this is equal to minus 3. And in terms of the coefficients of the quadratic, where a is equal to 1, b is equal to 3, and c is equal to 2, we can see that minus 3 is equivalent to just saying b, it's negative, divided by a. So this is equal to minus b of b divided by a, like that. Now we can also say that the product of the two roots together, so minus 2 times minus 1 is just 2. So we can say that minus 2 times minus 1 is equal to 2, and this is equal to c over a. So this forms the basis of the expressions that you'll see in a second for any sort of polynomial where you have the roots in terms of the Greek letters alpha, beta, gamma, and so on. So here I've written out the general expressions for a quadratic, a cubic, and a quartic. So I've also written out the roots. Now you express the roots in terms of Greek letters. So for quadratic, it would be alpha, beta. For cubic, it's alpha, beta, gamma. For quartic, it's alpha, beta, gamma, and delta. Now, using these roots, we can solve for certain expressions in terms of the coefficients of each polynomial without actually solving the polynomial itself. So these are given by the following equations that you can see over here. So the sum of all the roots, no matter which equation it is always equal to minus b over a, where b is the coefficient of the second highest x power. So alpha plus beta for a quadratic is equal to minus b over a, alpha plus beta plus gamma is equal to the same thing, alpha plus beta plus gamma plus delta is equal to the same thing for a quartic. Now the products of the roots in pairs is equal to c over a. Now in a quadratic we only have two roots, so that's just one pair is equal to c over a. For a cubic there's three pairs because there's three roots, so alpha beta plus beta gamma plus gamma alpha is equal to c over a. I've written alpha gamma, it's the same thing. And for a quartic you get six pairs, so all of these, alpha beta, alpha gamma, alpha delta, beta gamma, beta delta, and gamma delta, sum of all of that is equal to c over a. The products of the roots in threes is equal to minus d over a. Now in a quadratic you haven't got any threes, so you can't make any, that's just negligible. For a cubic you only have 1 3, so alpha beta gamma is equal to minus d over a. For a quartic you get four sets of 3, so alpha beta gamma, alpha beta delta, beta gamma delta, and alpha gamma delta. Sum of all of those is equal to minus d over a. Now the last one, which is only eligible for a quartic, is the products of the roots all combined in a 4. So alpha, beta, gamma, delta is equal to e over a. Now these equations you should memorize and be able to write out whenever you've got a question on roots of polynomials, and that will let you solve for certain expressions, like I said earlier, in terms of the coefficients without actually solving the equation. So here is an example of a quadratic, and we're going to go through a typical question that you could get in the exam on basically how to express certain expressions. So the first step we need to do is write out our coefficients just to make our life a bit easier. So we can say that a is equal to 2, b is equal to minus 5, and c is equal to minus 4. This basically just prevents us from making any mistakes when we bring out the numbers and the signs. So now we write out alpha plus beta is equal to minus b over a. I should mention beforehand that alpha and beta are the roots as well. Okay, so alpha plus beta is equal to minus b over a, and this is equal to minus 5 over 2. So that's equal to 5 over 2. And then the products of the roots together, alpha beta is equal to c over a, which is equal to minus 4 over 2, which is equal to minus 2. Now, let's say that we want to calculate 1 over alpha plus 1 over beta. So let's write that out. Now, I don't know how to do this because I've got alpha plus beta, but I want 1 over alpha plus 1 over beta. But what I can do is get the denominators the same, and you'll see why that actually makes our life easier in a second. So this is equal to times top and bottom by beta for this one, beta over alpha beta, plus top and bottom of this by alpha. So alpha over alpha beta. This is equal to alpha plus beta over alpha beta. Now you can see here that both of these are expressions I've already got. I know what alpha beta is, and I know what alpha plus beta is. So this is equal to 5 over 2 over minus 2, which is equal to minus 5 over 4. Now the next one says we need to find a value for alpha squared plus beta squared. Now again, I know what alpha times beta is, but I don't know what alpha squared is or what beta squared is. But what I can see is that both of these are squared, which means that I can write this in terms of a double bracket, which is squared. So let's say that this is equal to alpha squared plus 2 alpha beta plus beta squared minus 2 alpha beta. So I've made no overall change to this equation by adding in these 2 alpha betas. But now I can see that this expression here is just a quadratic, and it's a perfect square because I've got a middle term which is 2 times the first 2 numbers, and each of them are squared on both sides. So I can say that this is equal to alpha plus beta all squared minus 2 alpha beta. Again, I know what alpha plus beta is, and I know what alpha beta is as well. So this is equal to 5 over 2 squared minus 2 times minus 2, which is equal to 25 over 4 minus 4, which is equal to 25 over 4 minus 16 over 4. This should be plus. So minus 2 times minus 2 is plus 2. So plus 4 is equal to 16 over 4. 25 plus 16 is 41 over 4. Now, the key with these questions is to try and get the expression you've been given in terms of the expressions you've solved with the coefficients of the polynomial. So in this case, I got 1 over alpha plus 1 over beta in terms of the sum of the roots and the product of the roots, and same with this one. And that basically allows me to evaluate what the values will be. So another example here, and now we've got a cubic. So I want to find what the value of 1 over alpha plus 1 over beta plus 1 over alpha is. So again, I start by writing out my coefficients. A is equal to 2, B is equal to 3, C is equal to minus 4, D is equal to 2. Now, I can get all my expressions. So I can say that alpha plus beta plus gamma is equal to minus B over A, which is equal to minus 3 over 2. So minus 3 over 2. Then the products of the roots and pairs, so alpha beta plus beta gamma plus alpha gamma is equal to C over A. C is minus 4, so it's going to be equal to minus 4 over 2, which is equal to minus 2. Now the products of the roots and threes, or just the product of all 3 roots, alpha beta gamma is equal to minus D over A. And D is 2, so you're going to have minus 2 over 2, which is equal to minus 1. Now let's go back to this expression we had earlier. So again, similarly to the quadratic, if you multiply the top and bottom of each fraction by the missing roots, you can get an expression in terms of these 3 equations. So let's bring this down here and multiply the top and bottom of the first one by beta and gamma. So beta gamma over alpha beta gamma plus, and then the second one multiply the top and bottom by alpha gamma. And then the third one will multiply the top and bottom by alpha beta. And let's combine all 3 fractions. So I'm going to write it in a certain order so you can see why in a second. So alpha beta first, plus beta gamma, plus alpha gamma, all over alpha beta gamma. So now you can see that this equation is, or this expression rather, is the same as this one. This expression is the same as that one. So this is equal to minus 2, this is equal to minus 1. So this is equal to minus 2 over minus 1, which is equal to 2. And that is our cubic example.